Have you ever looked up at the night sky and wondered how it all began? Or how it might end? Our universe is a vast tapestry of stars, galaxies, and mysterious forces. It's so immense that our minds can barely grasp its scale. Yet within this cosmic ocean, we find clues about our own beginnings, and perhaps even our ultimate fate. Welcome to Astral Adventures, where we unravel the grand story of creation, evolution, and the possible demise of everything we know. Today we'll journey through billions of years, from the fiery birth of our cosmos to the distant horizons where it may all come to a close. Intro. In this chapter, we set the stage for our cosmic journey, pondering the origins and ultimate fate of the universe. The Big Bang, the moment that marked the birth of our universe, where everything began from a singularity. Imagine compressing everything, every star, every galaxy, and all of space into a point smaller than an atom. This is what we call a singularity. And around 13.8 billion years ago, it unleashed what we now refer to as the Big Bang. In a fraction of a second, energy and matter flooded into existence, and space itself began to stretch at speeds beyond our current comprehension. In those first moments, temperatures soared to trillions of degrees. Tiny particles called quarks, along with electrons, danced in a superheated plasma. As the universe expanded, it cooled enough for quarks to bind into protons and neutrons. Then, after a mere few minutes, simple nuclei formed, primarily hydrogen and helium. These basic elements became the seeds of everything that exists today, from distant stars to the cells in our bodies. It's important to note that the Big Bang wasn't an explosion into empty space. Space itself began expanding from this initial event. In many ways, it was the birth of time and the start of everything we experience. Though we've uncovered a great deal, much about these earliest epochs remains shrouded in mystery, inviting us to look ever deeper into our origins. The early universe and cosmic microwave background. In this chapter, we explore the universe's infancy, from the formation of the first atoms to the discovery of the cosmic microwave background. Fast forward to about 380,000 years after the Big Bang. By then, the universe had cooled enough for electrons to join with nuclei, creating neutral atoms, mostly hydrogen and helium. Before this point, the universe was like a foggy soup. Free electrons scattered light in all directions, making the cosmos opaque. But once those electrons latched onto nuclei, light could finally travel freely. This glow of first light is what we call the cosmic microwave background, or CMB. It's often described as the afterglow of creation, a faint radiation coming from every direction in the sky. When scientists mapped the CMB, they found subtle temperature variations that told us about the early density fluctuations. These tiny ripples in density would eventually shape the large-scale structure of the universe, seeding the formation of galaxies and clusters of galaxies. Observing the CMB today is like peering back in time, nearly 13.8 billion years. To see the universe as a newborn, covered in the faint impressions of its earliest days. Formation of stars and galaxies. This chapter explores how stars and galaxies came into existence, transforming the dark universe into a vibrant cosmic landscape. For the next few 100 million years, the universe was relatively dark. Gravity, however, was quietly at work, pulling together clumps of hydrogen and helium gas. Where these pockets grew dense enough, pressure and temperature soared until a critical point ignited nuclear fusion, creating the very first stars. These early stars, often more massive and short-lived than those we see today, lit up the universe and ended the so-called cosmic dark ages. When these stars died, some went supernova, scattering heavier elements, carbon, oxygen, iron, into space. Over countless generations of stellar births and deaths, the cosmos became enriched with the elements that would eventually form planets and, remarkably, life itself. Galaxies also began to take shape. Under the influence of gravity, stars grouped into spirals, ellipticals, and various irregular forms. Our home galaxy, the Milky Way, started to develop around 13 billion years ago, slowly accumulating the billions of stars we see today. Galaxies are like cosmic cities for stars, each containing anywhere from a few million to trillions of suns. Our solar system and Earth. This chapter explores the birth of our solar system and the formation of Earth, tracing the journey from a stellar nursery to the emergence of life. Roughly 4.6 billion years ago, one of these stellar nurseries gave rise to our solar system. A swirling cloud of gas and dust collapsed under gravity, creating our sun at its center. The remaining material coalesced into planets, dwarf planets, moons, and countless smaller objects. Our Earth formed in a sweet spot called the habitable zone, where liquid water could exist on the surface, an essential ingredient for life as we know it. Over time, Earth's molten surface cooled, oceans formed, and primitive life emerged. Tiny microbes that began a chain of evolution leading to incredible complexity. Every atom in our bodies, from the iron in our blood to the calcium in our bones, was forged in ancient stars. Indeed, we are stardust come alive, a testament to the universe's grand recycling of matter. Dark matter and dark energy. In this chapter, we explore the unseen forces that shape our universe. As we look deeper, we realize there's far more to the cosmos than meets the eye. Galaxies spin faster than they should if only visible matter were present. Something unseen exerts gravitational influence, something we call dark matter. Though we don't know exactly what it is, it's clear that it plays a crucial role in holding galaxies and clusters together, shaping the large-scale structure of the universe. But there's an even stranger phenomenon at work. Observations of distant supernovae revealed that the expansion of the universe isn't slowing down, it's speeding up. A mysterious force dubbed dark energy is driving galaxies apart at an accelerating rate. Dark energy, whatever its true nature, makes up around 68% of the universe's energy content, while dark matter accounts for about 27%, leaving a mere 5% for everything we can see: stars, planets, gas, and us. Scientists have proposed all sorts of theories, from vacuum energy to new fields in physics. But so far, no one can say for certain what dark energy truly is. It's one of the greatest puzzles in cosmology, reminding us that the universe still holds many secrets. End of the universe. Theories. In this chapter, we explore the possible scenarios for how the universe might meet its end. All stories have an ending, and the universe is no exception. But how might it end? Several theories compete for the final chapter, Big Freeze, also called heat death. This scenario suggests that as the universe keeps expanding, galaxies drift ever farther apart. Stars will eventually use up their fuel, and black holes will evaporate over unimaginable eons. In the end, only cold, diffuse radiation remains. No structure, no light, just a silent void stretching into eternity. Big Rip. If dark energy grows stronger over time, it could overcome all forces holding matter together. Eventually it would tear galaxies, stars, planets, and even atoms apart. This cataclysmic ripping would mark a violent end, leaving nothing but dispersed fundamental particles. Big Crunch. In a less likely scenario, if there's enough matter, and the expansion somehow reverses, the universe might collapse back into a super-dense state, potentially triggering another Big Bang. This cyclical model envisions endless rebirth, though current data hints that accelerated expansion will prevent this. Which fate awaits us remains uncertain. But thinking about these distant possibilities underscores just how vast cosmic timescales are, trillions upon trillions of years beyond our comprehension. Conclusion? In contemplating the birth and death of everything, we realize our place in this vast story. We occupy just a tiny moment in cosmic history, shaped by events set in motion billions of years ago. Yet, the universe's epic tale continues to unfold, and our understanding of it continues to grow. As we gaze at the stars, we're reminded of the deep connections we share with each other and with all matter in the cosmos. It's a humbling, yet exhilarating thought. Thank you for joining Astral Adventures on this journey through time and space. Be sure to subscribe for more explorations of the unknown, and remember, every question we answer reveals countless more waiting to be discovered. Until next time, stay curious, fellow adventurer.